All right, Unit 2B, Day 7, inverse functions. I got, you know what? I was just about to say how neat my work has become as I circle this with what looks like a sideways looking peregrine falcon of some sort here. Or maybe penguin. Turn your head. Anyway, I tried. Okay, Unit 2B, Day 7, inverse functions. Inverse functions are functions that map the domain on the range or range on the domain. So they work this way. Let's say I want to figure out something, and I want to say how long does it take to, I'm in chemistry class because I failed math class, so I had to take chemistry. I kid, I'm in chemistry class and I'm warming something up and I put it underneath a Bunsen burner, okay, a Bunsen burner. And here it's being warmed up, and then you find that after a certain period of time, you have independent variable time, and after 10 seconds, your temperature is 29 Kelvin or 291 Kelvin, because as chemistry people know, Kelvin, everyone uses Kelvin. It's the way of the future. Okay, it's caught on well. Just like the Betamax. So after 10 seconds, we're at 291 Kelvin and blah, blah, blah. So then you do make a formula to figure out. I put something in, warm it up on this Bunsen burner, and after a while, it heats up. Okay, that's what we do in chemistry class. But in math class, what we can do is we can work backwards. We can come up with a formula that says, okay, you know what? I want to get to 291 Kelvin. How long do I have to warm this thing up for on this Bunsen burner, capital B, Bunsen? And we're going to come up with an equation that goes from dependent to independent. Okay, and that's what we can do because we're math people. And how does that work? Well, that works this way. You take your formula. So if I had a formula like this, f at x is equal to 2x plus 3, I would say, give me an x value, jam an x value in here. So let's say I'm going to have, let's say 5. And I come out and I say that's 10 plus 3, that's 13. Okay, but now what I want to do is, so whatever that in real life situation, I have 5 somethings, and then I end up with 13 something else. Okay, but let's figure out that now I end up with 13 at the end. How many do I have to start off with? Okay, and that is a backwards function or inverse function. And what we're going to do is come up with an equation, and we'll leave this here, and we'll make sure that this works. If it doesn't, quite honest, I will just delete the video and start again. So first thing you do is replace f at x with 2x plus 3. And what you want to do now is we're going to work backwards, and to work backwards, we're going to replace y with x and x with y. Anywhere you see a y, you put an x, and anywhere you see an x, you put a y. So now we're working backwards. And then the next step is to isolate for y. So I have x equals all this, but at the end I want y equals something. Now you can rearrange these, but we're smart enough to know that if you end up with y equals a bunch of stuff, that's the same as having a bunch of stuff is equal to y. So I look over here, and I'm quite happy with the y being on this side. So the first thing I'll do is move that 3 over, and I end up with this. Then I have 2y, and I need to divide, so I end up with this. Okay, and that is that, and that's my new function. Okay, so that's my inverse function. And to denote the inverse function, we do this. This is f to the negative 1, x means the inverse function. So that is the inverse function of, of my original function is equal to this guy right here. And is it true? Well, let's see. If I put 13 in, I go 13 minus 3 divided by 2, and I get 10 divided by 2, and I end up with 5. So working backwards, remember what we wanted to see was if I ended up with 13, what did I start off with? And the answer was 5, and that was right. Because remember, I said if I put 5 in here, I ended up with 13. Okay, so there's your Bunsen burner question. Okay, you'll never overcook the pasta or whatever. Okay, so that's that. It gets a little more confusing. Well, actually, let's graph these. Okay, so there's 2 ways to look at this. One is this is a line, but it looks a little funny. So if you're going to rewrite this, I have x minus 3 over 2. That's also x over 2 minus 3 over 2. So I'm just going to break this guy down now. So it looks like y equals mx plus b form. And that's the same as 1/2 x minus 3/2. So that's a bit ugly, I got to admit. So I have here, this here is fine. There's nothing wrong with this, but it's just not in this form. This form here, you could tell me what it looks like. If I was to graph, so what did I have here? 1/2 x minus 3/2. So let's go to the next page. I had 1/2 x minus 3/2. And I was to graph that, you would tell me that I go to negative 3/2, and I have a slope of 1/2, so something it's fairly flat. So you would graph something like this. And my first line was what? 2x plus 3. So this will be hard to see actually here. But 2x plus 3, and I had a slope of 2. So I had 2x plus 3. Yeah, so 2x plus 3. So I go up to 3, and I had a slope of 2. So it looks something like this. And this is really hard to see here. But if you notice here, I know you can't see here, but let me just show you. Let me show you on Desmos what is going on here. So I have 3. Oops, what's going on here? My mouse. 3x plus 2. Enter. Oh, it hates capitals. I have cap lock on here. Yelling at people all the time. 3x plus 2, and then this guy here is, we said it's half, so I'm going to go 0.5x, and then what did I have? Plus 3 halves, so 1.5. So it looks like that. Did I mess it up? I sketched that. Let me just go back here. I probably did. Where am I? Give me a second. Like that. Over here. Wrong. That's yesterday's. Minus 3 halves. So what's the problem here? Oh yeah, minus 3 halves. Minus that. So it looks like that. Okay, so I don't know if you can notice here, but these guys here, if I had an imaginary line and I drew it through here, x equals y, I could flip these and they would reflect on each other. Okay, that's what happens with the reflection with an inverse. What is that? That's weird. That was my continuation of my AC/DC video from earlier. I just kept playing. So be careful with that. Okay, so where am I? I got confused by that. What's going on here? Okay, that was weird. Let's get back to this, inverses. Okay, so let's get some more inverses here, and then we'll graph them. Hopefully it makes a little more sense when we graph them in a bit. But let's look at our parabolas. The main thing we want to look at is parabolas, because then when we look at tomorrow's work, what's going to end up happening is we're going to cut arms off parabolas to make them function. So a parabola is going to look like this, and then we're going to flip it sideways. So it's going to look something like this. Okay, and then we realize that this guy, the sideways guy, is not a function. So later on, we're going to chop an arm off of one of these. We'll chop an arm off here, and then we chop an arm off here, so that the inverse is itself a function. Okay, so that's you gotta wait till tomorrow for that one. Okay, so let's go back to this now. My parabola, my basic parabola. My basic parabola. Give me a second here. Is y equals x squared. Okay, so y equals x squared, and we graph that one. Let's go to Desmos real quick. We'll graph y equals x squared. Y equals x squared, so x squared, and then I can just get rid of this guy here. That's our basic parabola. Good, and we're going to draw the inverse here. So we're going to get the inverse going here, and the inverse, change x for y, and then solve for y. So x equals y squared, and then now we're going to solve for y. And what we'll do here is x equals y squared. We need to get rid of the y squared, and the opposite function of a squared is a root. So we take the root of each side, and x equals y. Now you have to be careful there, because the root of x, when we do this, we need to include both the negative and the positive, right? Because if I said x equals y squared, and I had -3 as my y, if I subbed in -3 for my y, x would be 9. But if I just say the root of x is equal to y, then I'm saying the root of 9 is equal to 3, which is true, but going backwards, I had -3 squared equals 9, which I probably just confused you more or less. But when you take the root of each side, you have to add the plus or minus, okay? And it's getting even more confusing because I have, I'm setting up y as my independent variable. Okay, so there is that, and how does that look? Let's see how that looks when we graph it. Over to Desmos. Again, we're going to add another one here, and we'll do expression, and we'll add root x, and that shows up here. Now, so I don't know how to do this, so I'm just going to do it 2 different ways. I'm just going to add another item right now, and I'm going to add to it minus root x. So minus root x, and then together, pretend this is the same color. I think I can make it the same color. Let me see. No, just make it disappear. Together, they turn into plus or minus root x. So the inverse of this guy is this guy. So this green guy, the inverse of the green guy is the purpley orange guy. And if you could do this, you would notice if I drew a line right through here, x equals y. Oop, no, touch that. I could fold the green guy over and it would turn out to be this right here. Where it gets a little more confusing is when the formulas themselves become a little more confusing. So when I get things like this, y is equal to, from our notes, we had something like this, x squared minus 5, and you want to change that, x equals y squared minus 5, and you solve this, that becomes x plus 5 is equal to y squared. Take the plus or minus square root of each side, so that becomes this. Okay, and then you just graph that, and that is the inverse of x squared minus 5. Okay, and it turns out to be something that looks like that. And we know what this looks like now, right? Because this is the square, this here is going to be left 5. You take your root, your basic root x, and you move it left 5 here, okay? And now I want the plus and the minus. So there's the plus. The minus in front of the whole thing means vertical flip, or flipping the x-axis. And that turns into this like this. Okay, so the inverse of x squared minus 5 is this red guy that I just put here, which is plus or minus the square root of x plus 5. Okay, so those are inverses. You play around with them like that. Let me just do one more. If I start off with y, or f at x is equal to, and don't forget, we use function notation, so a lot of times we start off like this. The root of x, and the one in our note was x minus 2 is in here, okay, underneath the bracket. Here, that's y is equal to x minus 2. Switch your y for x, so x equals root y minus 2. And now I want to get rid of this, and what I have to, or solve for y, what I have to do is square each side, so I get x squared is equal to, this square just removes the root sign, and I get x squared is equal to y minus 2, x squared plus 2 is equal to y. And that is the answer to this inverse, but that's not entirely true. And you're going to have to wait until tomorrow's episode of math with me to figure out why that's not true. See if you can figure it out. Okay, graph them and see what happens. And have a nice day.